This video is going to show you how to create a function to calculate the voltage at a point in a voltage divider. So looking back at this voltage divider, and let's look back at this. Let's start with our 1K voltage divider from one of our previous videos. So here I've got a resistor and resistor 1 and resistor 2, each 1,000 ohms. And I have my starting voltage. So when I want to calculate this voltage here at this point, right, I need to say V2, so the voltage across here is the same as VB, is equal to the total voltage times R2 over R1 plus R2. So those are the values that I need to plug into my function when I go into MATLAB. So in MATLAB, I want to create a function that calculates the voltage at that position, VB. So what I'm going to do is I'm going to type function. And now I want to say VB is equal to, I'm going to call this vol divider. And I need to have inputs. And so looking back here at my circuit, the inputs that I need are the total voltage of the circuit from the battery, this voltage, and the resistance of each of the resistors. And that's basically all I need to create my function. So those are going to be my variables that I'm going to input into this function. So I'm going to call this V source, R1, and R2. So now when I want to do some calculations, looking back here, I want to calculate the equivalent resistance, because that's what I'm going to put here, right in the denominator. I need REQ. So REQ is R1 plus R2. So let's define that. And so we'll say REQ is equal to R1 plus R2. Add our semicolon so it doesn't print it out. Now the next thing I want is I want to calculate my current. So my current is my source voltage, is 9 volts, divided by my REQ. I'm going to put that in there. So my current is equal to Vs, that's from my variable here, divided by REQ. And that's calculated here. And now finally, how do I calculate VB? Looking back, my VB, or V2 here, is my total voltage V times my resistor 2, that's resistor 2, divided by my equivalent resistance. So I need, this is my V source, Vs, this is R2, and this is our equivalent. Let's add that in. Vs times R2 divided by REQ, and end. So now if I want to run this function, I need to save it. And when I have a function, I need to save it with the same name as the name of the function here. So it has to have the same name. So I'm going to call this vol div. Right, and now if I want to run it, I'm going to say vol is equal to vol div, and I'm gonna plug in the values that we just used. So I'm going to say my Vs is 9 volts, R1 is 1,000, and R2 is 1,000. Notice down here you can see that it's prompting me for the values from my own function. So when I plug it in, my voltage is 4.5. If I go over here and look, I calculated 4.5. So let's try now, now that we have this function, we can calculate it pretty quickly for our other circuits, our other voltage dividers. So in this case, my R1 is 3,000, my R2 is 6,000, and my source again is 9. So let's run that again. Vol is equal to, and I don't even have to type that. I can just do up arrow and then swap out my values. So just looking back, I think I said 3,000 and 6,000. I'm going to change this to 3,000, change this to 6,000, run it, and I should get 6 volts. So let's see if we do. And we get 6 volts. So let's, the next one that we did is we swapped them, and we made the first resistor 6,000 and the second resistor 3,000. And we run that, and we get 3 volts. And that's what we calculated here when we switched them. We had 6,000 here, 3,000 here. We calculated 3 volts. Let's do our last voltage divider. We had 100 and 220. So I'm going to go here again, 100 and 220, and I get 6.1875, and that's what I calculated here. I rounded to 6.2. So that's how we make a function that can calculate the voltage at a point. Now we want to think about how can we do this to go through all of the circuit, all of the resistors in your kit, making voltage dividers in all the different kinds of combinations. How could you use this function and write a script to call this function, say in a for loop perhaps, to do that calculation?